All right, so today we're going to talk a little bit about an alternate way to think about sine, cosine, and tangent and getting the values for those special angles, the quadrantals, and all of those angles in the unit circle that correspond to a special angle. So 30, 60, 45, and then all of those angles in quadrant 2, 3, and 4. So we've been working with the unit circle, and hopefully we've gotten into a pattern that we can use. There's another way to kind of get through this. And it really just involves knowing your sine, cosine, and tangent values for quadrant 1 and your quadrantals. So your 0, 90, 180, 270 angles, right? So let's talk about those. Let's get those in here. And then we'll talk about how to use them to get values of other angles. Okay? All right, so first, at 0 degrees or 0 radians, sine, cosine, and tangent, we know that the coordinates there, because the unit circle has a radius of 1, is 1, 0. We know that sine is the y, so that means that sine of 0, or 0 radians, 0 degrees, 0 radians, is y is 0. Cosine of 0 degrees or 0 radians is 1. Tangent is what we get when we take sine over cosine. Well, sine over cosine gives you 0 over 1, or just 0. Now moving on to the next quadrantal, the positive y-axis, 90 degrees, pi over 2, the coordinates are 0, 1. We know that the sine of 90 degrees has to be 1 because sine is the y-coordinate. Cosine is going to be 0. Tangent is sine over cosine. So 1 over 0, or undefined, right? Now, the next quadrantal, 180, pi. Coordinates there are, we're going back on the x-axis, so in the negative direction. So sine is 0, cosine is negative 1. Tangent is going to be 0 over negative 1, or just 0. And then for the next one, your coordinates are 0, negative 1 at 270, or 3 pi over 2. So sine is negative 1, cosine is 0, and tangent is negative 1 over 0, or again, undefined. Okay, now, the specials in quadrant 1, 30, 45, and 60. So the coordinates at pi over 6, or 30 degrees, are radical 3 over 2, 1/2. Right, so that means that the sine of 30 is 1/2. Cosine of 30 is radical 3 over 2. And now tangent is supposed to be sine over cosine. So 1/2 over radical 3 over 2. We simplify that fraction however you want to do this. Since they have common denominators, you can just wipe those out. So you get 1 over radical 3. And then when you rationalize, you get radical 3 over 3. Okay? And then 45 degrees. The coordinates are radical 2 over 2, radical 2 over 2. So sine of 45 degrees is just radical 2 over 2. Cosine is radical 2 over 2. And when you divide y by x, if you divide sine by cosine, you're just going to get 1 because you're dividing something by itself. And then pi over 3, or 60 degrees, you're at 1/2, negative radical 3 over 2. That means sine is radical 3 over 2, cosine is 1/2. And again, if you divide sine by cosine, you've got to flip this guy over and multiply, divide out the 2's, and so you get radical 3. So tangent is just radical 3. Okay? These values, if you just know this table, sine, cosine, tangent, for those angles, and you remember this that we've seen before, a smart trig class, which tells you that in quadrant 1, all functions are positive. In quadrant 2, just the sine function is positive. Quadrant 3, just tangent is positive. And in quadrant 4, just cosine is positive. Really can help you think through and find your sine, cosine, and tangent without thinking about the entire unit circle. Okay? How? Well, We do that by getting to what's called a reference angle, right? Every angle in the unit circle, or every angle anywhere, can be reduced down to its reference angle. And the reference angle is an acute angle that is formed by the terminal side and the x-axis. That's the definition, right? So no matter where you are, in terms of an angle and standard position, if you're in quadrant 1, then this would be your reference angle. Okay, so then that would be your reference angle. If you're in quadrant 2, then your reference angle would be that angle measure. That would be your theta prime, and that's our annotation for a reference angle. Okay? If you're in quadrant 3, then we're still looking for this angle to the x-axis. So that would be your reference angle. And in quadrant 4, we're looking for this angle. That would be your reference angle. So that would be your theta prime. Okay? Now, that being the case, how do you come up with a reference angle? And I want to use those examples to help us think through it. Okay? So if theta is in, and there's 4 situations I just walked you through. Number 1, if theta is in quadrant 1, then the angle and the reference angle, which is an angle formed by the terminal side and the x-axis, are just the same. Okay? Now remember that your reference angle has to be an acute angle. So any coterminal angle that's in quadrant 1, we're going to have to reduce down to an acute angle. We'll talk about that in a second. The second situation is if your angle is in quadrant 2. Right? And if your angle is in quadrant 2, this is the angle measure. We want that angle, right? Well, how do you get that? Well, from geometry, this blue angle and the purple angle are going to add to 180. They're a linear pair, right? So to find the blue arrow angle, or the reference angle, I would want to take the original angle, theta, and subtract it from 180. When you do that, that would give you your reference angle, theta prime. Okay? All right, now, what if we're in quadrant 3? Let's think about this. Let's set this up. Quadrant 3 means that my angle will be here. So this is my original angle, but I only want that angle. That would be your reference angle because it's being formed by the terminal side and the x-axis. Well, to get the green angle, well, to go all the way from the whole angle takes me past 180, right? So how do we do that? If I take 180 out of this angle, then I'll be left with the last little piece right here that would give me my reference angle. So what does that mean? That means that I want to subtract my angle, I want to subtract 180 from the original angle, and that would give me theta prime. Okay? And then for the last situation is if we're in quadrant 4. Right? So let's get rid of all of this. Let's draw our angle in quadrant 4, and let's think about this for a second. This is our angle in quadrant 4. The angle that I want is this right here. That's going to be our reference angle. So it's our angle and then plus whatever we have left to get to 360. So to find the reference angle here, I just want to take my original angle measure and subtract it from 360. Okay? Now, all of this pertains to the most basic coterminal angle, right? So if we have a coterminal angle, if we have an angle measure that's more than 360 or more than 2 pi, then we need to reduce that down to its coterminal angle that's less than 360 or less than 2 pi, and then we can apply our rules here, all right? Remember, we're always looking for an acute angle. So, for example, 4 pi over 3, right? If I want to find, now, first of all, 4 pi over 3 is less than 2 pi, so I don't have to worry about getting coterminal angles. What I do have to figure out is what quadrant is 4 pi over 3 in. Well, 4 pi over 3 is like 1 and 1/3 pi, so 1 pi and another third puts us in quadrant 3. And in quadrant 3, we're supposed to take our angle and subtract 180 from it. Now, I forgot to say this. 180, of course, is in terms of degrees. In radians, we can always replace 180 with, I need to back up for a second, with pi, right? Because pi and 180 are the same. And we can replace 360 with 2 pi, right? So I'm supposed to subtract 180 from the angle to find the reference angle, or subtract pi. We'll get a common denominator, subtract that out, and you get pi over 3. Okay? So there you go. If I want to find the reference angle for 13 pi over 6, now hold on a minute, 13 pi over 6 is more than 2 pi. So I need to first consider the coterminal angle that's less than 2 pi. So I want to subtract from 2 pi first, which means I'm subtracting 12 pi over 6, which gets me pi over 6, right? So my coterminal angle is pi over 6. To find the reference angle, what quadrant are we in? Well, pi over 6 is in quadrant 1, which means that our angle and our reference angle are the same. Okay? And next radians guy is 7 pi over 6. 7 pi over 6, we got to know what quadrant we're in. And again, we're in quadrant 3. And so since we're in quadrant 3, we need to subtract pi from it. If you subtract pi from 7 pi over 6, you're going to get pi over 6. And I hope we're starting to see a pattern here. For your reference angle, if we're in radians, then your reference angle is always going to be whatever the denominator of your radians measure is, right? 4 pi over 3, the reference angle was pi over 3. 13 pi over 6, the reference angle was pi over 6. 7 pi over 6, the reference angle was pi over 6. If I wanted to know the reference angle of 227 pi over 4, it would just be pi over 4, right? If I want to know the reference angle of 2,164 pi over 9, it would just be pi over 9, right? It's just whatever the denominator is of your angle is going to be your reference angle, if that makes sense. So that's our quick way of finding our radians reference angle, okay? Now, if we're in degrees, we can go back to our original 180 plan that we had there. 405 is bigger than 360. So first of all, we've got to find the coterminal angle here that's less than 360. So subtract 360 from it, we get 45 degrees. 45 degrees is in quadrant 1 because it's less than 90, which means our reference angle and our actual angle are the same. Okay? I think this is supposed to be 120 degrees here. Now, even negative 120 degrees. Negative 120 degrees would actually put us in quadrant 3, right? Quadrant 3 says that we're supposed to subtract 180 from this. But think about that. If I subtract 180 from negative 120, I'm still going to be negative. And we want our reference angle to be positive, right? So instead of subtracting 180, we have to be smart. Since our angle is already negative, add 180. And so our reference angle becomes 60 degrees. All right? And last but not least, our angle is 205. Again, this guy is in quadrant 3. So subtract 180 from it, and we get 25 degrees. Okay? So that's how we find our reference angle. And I know 25 degrees is not a special, but every angle has a reference angle. It's our way of kind of bouncing back into quadrant 1. Okay? Now, how do we use it? Well, if I want to find, say, the secant of 7 pi over 3, then I want to get to the reference angle, right? To get to the reference angle, first, that's more than 2 pi. So I'm going to subtract 2 pi from it, which means I'm going to make this 6 pi over 3. Subtract that, you get pi over 3. So my reference angle, now this angle is in quadrant 1. This original angle, 7 pi over 3, was in quadrant 1. I knew that already. So my reference angle and my angle measure end up being the same, if that makes any sense. So pi over 3 is the reference angle. And since secant is the reciprocal of cosine, I have to remember that cosine of pi over 3 is a half. Right? Now, a smart trig class says that if we're in quadrant 1, everybody's positive. So I am going to take the positive version of that value, 1/2, and make that where I start. Now, secant is the reciprocal of 1/2. Right? It's the reciprocal of cosine. So now I got to flip it over and get 2. It's a thought process. It's a long process, but it's certainly still a thought process. Now, I know your notes say 13 pi, but I'm going to change this over to 7 pi over 6 because I want it to be a non-coterminal angle. So if I want to find cosecant of 7 pi over 6, well, we can use what we just said a second ago, which is any radians reference angle, it's just going to be where the denominator is. So my reference angle here is going to be pi over 6. Cosecant is the reciprocal of sine. Sine of pi over 6 is 1/2, right? Now, what quadrant are we in? 7 pi over 6 puts us in quadrant 3. And in quadrant 3, a smart trig class says that tangent is the only guy that's positive there. Right? So that means that sine of 7 pi over 6 is going to be negative 1/2. And to get cosecant, we flip that over. So cosecant is going to be negative 2. All right? All right. And probably ought to change this as well. Let's do 315. Okay, cotangent of 315. Well, 315 puts us in quadrant 4, which means that, unless it's a coterminal angle, which it's not, it's less than 360 already, means that I want to take 360 minus my angle to find my reference angle, which is going to be 45 degrees. So theta prime is 45 degrees. And at 45 degrees, we've got, cotangent. Tangent of 45 degrees, because I need the reciprocal of tangent for cotangent, is 1. Right? Now, we're in quadrant 4. So the tangent of 315, a smart trig class says that cosine is the only guy that's positive in quadrant 4. So that means that tangent of 315 has to be negative 1. So to find cotangent of 315, I flip negative 1 over and it still stays negative 1. So another thought, it's just a different thought process with getting through your sine, cosine, and tangent values. And so you don't have to memorize the whole circle, just memorize one quadrant and think your way into that quadrant. Still a lot of thinking, okay? But that's reference angles. Okay? The other thing that we want to do with this set of notes is remember back to before we got into the unit circle and how to find sine, cosine, tangent, cosecant, secant, and cotangent for an angle that has a point on its terminal side that does not correspond to the unit circle, right? In other words, we know that if we're in standard position with our angle, that with the unit circle, there are points that are on that terminal side that are also on a circle. Can I draw this and make it make sense? Right? Where the radius is 1. Well, there's more than one point on that terminal side. So I could consider a different point, like right here, that's not with a radius of 1. So if I drew a circle now, and tried to correspond it there to a circle that makes sense, something like that. Now this radius is not 1, it's just r. Okay? So what happens then? Well, there's still a point on the circle and on the terminal side together. So what happens if this radius is not 1? That's the question. Right? And we've done this already. So this is a set of coordinates, x comma y, where we know that we have to go over x and up y to plot the point, which does create a right triangle. Here's our angle, right? And then this is going to be the radius of some circle that corresponds to that angle with that terminal side length. Okay? Now, that means that if we want to go through sine, cosine, and tangent, you can see how that ratio actually shakes out here. Sine is opposite over hypotenuse, so y over r. Cosine is adjacent over hypotenuse, so x over r. Tangent still y over x. Okay? And then, of course, cosecant, secant, and cotangent are just reciprocals of that. So what does that mean? It means we have to know what r is. Well, if you go to this right triangle and you wanted to find r, then you could just use Pythagorean theorem. Or square root both sides to get just r, and you're going to see what you see in the box there. And that is r comes from squaring x, squaring y, add them together, and square rooting. And the x and y will just come from the point that's on the terminal side. Once we have r and those coordinates, then we can put together sine, cosine, and tangent. All right? So let's try this out. Now you have to skip around a little bit, like you did for your reference angle examples. Skip down to these examples here. And the first one we come to says that the point 1 comma negative 3 is on the terminal side of the angle. So since the coordinates are 1 comma negative 3, I already know I'm not in the unit circle because it's not a radical 3 over 2 or a radical 2 over 2 or 1/2 or whatever. So I'm going to have to find the radius so that I can come up with my ratios. X squared is going to be 1 squared plus y squared is negative 3 squared. So 1 plus 9. It's just radical 10. Okay? Now, if I want to find the sine of this angle, whatever it is, we don't know what the angle is, we just know where the point is that's on the terminal side, I've got to do y over r. That's what the last slide just reminded us. Well, y is negative 3. R is the square root of 10. And so when you rationalize, you get negative 3 radical 10 over 10. Cosine is x over r. X is 1, r is radical 10. When you rationalize, it's radical 10 over 10. Tangent is y over x. Don't even need r. So negative 3 over 1 is just negative 3. Now to get the other 3, you're just flipping over the previous 3. Cosecant goes with sine, so just flip that over before you have rationalized. Would be easier, so you don't have to rationalize again. So you just get radical 10 over negative 3. Secant goes with cosine, so it's going to give you radical 10 over 1 when you flip cosine over. Cotangent goes with tangent, of course, so just flip that over and you get negative 1/3. And that's how you come up with your trig values, your ratio values. Okay? Now, you try. Now let's say that a point on the terminal side is negative 2, negative 5. Find the exact value of each of the 6 trig functions. So take a second. And see what you come up with. Stop the video. You can start it back up and check all your answers. Did you get these values? Sine, negative 5, radical 29 over 29. Cosine, negative 2, radical 29 over 29. Tangent, 5/2. Cosecant, negative radical 29 over 5. Secant, negative radical 29 over 2. And cotangent, 2 over 5. If you didn't, come in and see me. We'll figure out why not. Okay? Those are the 2 big ideas coming from what we want to talk about today. Some other things that you want to just be able to think through and do. And there's so much that we can do with this unit circle and sine, cosine, and tangent values. Okay? So just want to be able to answer some of these questions. Name the quadrant in which theta lies if the cotangent is positive and the sine is negative. Remember, a smart trig class. If sine is negative, that means we can't be in this or this, right? Because A means everybody's positive, S means sine is positive. So we've got to be in one of those 2 quadrants, right? Well, this says that cotangent is positive, which means that tangent had to be positive. That means we have to be in quadrant 3, right? Same thought process for the next one. We'll name the quadrant in which theta lies if tangent is, and that basically means that tangent is negative and cosine is negative. So a smart trig class, well, since there are negative values here, then we can't be in quadrant 1. If tangent is negative and cosine is negative, that means the only guy left to be positive is sine, and that puts us in quadrant 2. Okay, so just we need to be able to think through that. All right, now another way, problem that could be posed here for you is if cotangent theta is negative 4 over 3. Now remember that tangent is y over x. That means cotangent has to be x over y, which means that if cotangent is negative 4 over 3, then our coordinates for our point on the terminal side must have been negative 4, comma 3. And in order to find everybody else, we have to have r, right? Because that's not a special point. So we go negative 4 squared plus 3 squared. 16 plus 9 equals r. And then square root that, and r is going to be 5. Now, it should be plus or minus 5. Okay? But since sine is positive, tangent apparently is negative, right? That means that if sine is going to be positive, and sine is y over r, y is already positive 3. That means that we can't let r be negative 5. It's got to be positive 5. So we can get rid of the plus or minus. Cosine. Cosine is x over r, so 3 over 5. Secant is flipping over cosine, so 5 over 3. Cosecant is flipping over sine, or, hang on a minute. Back up. Sorry, cosine is x over r, so it should be negative 4 over 5. Secant coming from that should be negative 5 over 4, and this should be 5 over 3. Sorry, small slip. Okay, so just trying to think through some problems, and this example we've already done. So just the last couple, secant and cotangent of the following four quadrantals at 0 degrees. You have to remember that sine is 0 and cosine is 1, and tangent is 0. That means that secant has to be the reciprocal of 0. Sorry, has to be reciprocal of 1, because secant is reciprocal of cosine. So flip that over, you're still going to get 1. Cotangent there, well, tangent is 0. You flip 0 over, you get 1 over 0, which is actually undefined. Right? These are all the quadrantals. At pi, right, secant is taking cosine and flipping it over, so you're taking -1 and flipping it over and getting -1. Cotangent is actually x over y, so -1 over 0 is again undefined. Pi over 2, your coordinates are 0, 1. So if you flip over 0 to get secant, you're going to get 1 over 0, which is undefined. Cotangent means that we're taking x over y, so 0 over 1, which is 0. And last but not least, this quadrantal, secant means we're flipping over cosine, so this is going to make this undefined again. And cotangent means we're taking x over y, so 0 over -1, which is just 0. Okay? And so there you go. Homework's out in Canvas. Knock it out. We'll talk about any questions you got in next class.